Hi, today I want to talk about, let's say, work done. What is basically what is work done? Okay, work done is basically when energy is applied, when the force is exerted and work is done. So work done, we calculate work done by taking the force multiplied by the distance from the point of application. So work done is force multiplied by distance. Now let us suppose you have an object, and let's suppose that the object its weight is 250 kilograms. Now this object is pulled up, okay, to a distance, to a height, let's say distance or height rather, of 30 meters. There's also the gravity acting down on the force, and we know that gravity is 10, all right, or 9.8 meters per second square, so 10. So acceleration due to the force of gravity, which is a vector basically, and so we have that force acting on this object, on its weight, and the object is pulled up 30 meters. So what we need to find is calculate the work done. Okay, what's the work done against gravity? So the force of gravity we know is 10, multiply by 250 because it's acting on its weight, and then you multiply by the distance. All right, so suppose we do this, we get 10 times 250 times 30, 75,000 joules, and the unit is joules. All right, now let's say this is our question number 1, and I want to move on to question, let's say, number 2. I have this time, let's say for example now, an object on a horizontal surface, and let's suppose that the object has a weight of 350 newtons, and this object, all right, now is let's say pulled to a distance. It comes here, right? It's pulled, and let's say that the distance is 12 meters. Okay, and now we want to find the work done by the force. Find work done by the force. Of course, it's a force where work done by the force is going to be the what we explained before, force multiplied by the distance. All right, so the force multiplied by the distance is 350 times 12. So if I have to say 350 times 12, and that's going to come to 4,200 joules. Let's suppose now we have a third situation, all right? Let's suppose now a body of mass 40 kilograms is attached to a string making an angle of 25 degrees to the horizontal. Let's say now that this is the body, but instead there's a string attached to the body at a horizontal angle of 25 degrees. All right, so now what we're going to do, the body is moved, let's say 30 meters. So say we move this to a distance of 30 meters, comes here and rest here, so 30 meters. All right, and now we want to find, and let's say further that the string in the, the force in the string is 80 newtons. All right, so how are we going to find the work done by the tension in the string? And further, let's say that this body here is 40 kilograms. All right, so it's being pulled. So what we're going to find is the component of the force here, which is basically 80 multiplied by cos of 25. And then we're going to multiply this by its distance. Okay, and the distance is 30 meters. So that's basically it. We just want to find the work done by the tension in the string. All right, so work done by the tension in the string is going to be all of that. Simply apply this in your calculator. 80 times cos of 25, okay, times 30, should be able to get 2,175 joules. So 2,175 joules.